Hi, Stepsters. I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today, we'll be looking at acids, bases, and solution. The fun world of chemistry. Get it? PHN? The fun? Okay, let's continue. Ever wonder what makes lemon sour or soap slippery? Get ready to explore the amazing world of chemistry that surrounds us every day. We'll discover fascinating substances, conduct cool at-home experiments, and uncover the colorful science behind acids and bases.
So, what are solutions? A solution is a uniform mixture where one substance dissolves into another. When you mix ingredients that blend completely, you've created a solution. A solution is created by mixing a solute into a solvent. A solute is a substance that dissolves, for example, sugar or salt, and the solvent is the substance that does the dissolving. So, like water, which is known as the universal solvent, or even coffee or any other thing that you might be using as your solvent. So, for example, when you're making coffee, your solvent would be something like milk, and your solute would be the tiny um, coffee powder. Now, try this. Stir a spoonful of sugar into water and watch it disappear as it forms a solution. The sugar is still there, but it's dissolved, so you can't see it anymore. And if you keep adding sugar, you'll notice that no matter how much you mix, some of it is left in the bottom. That is because the solvent itself has a capacity, so it cannot hold more than a certain amount. And you will learn about that later, but just for a tiny explanation, if you ever see that no matter how much you're mixing, the sugar just doesn't mix into the water, that's because the water has had enough sugar and it cannot have any more. So think about when you eat lunch. You've had enough and your mom tries to give you more. You just can't have it, can you?
Now let's meet the acids. The characteristics of acids. They often taste sour, like lemons, and they can be corrosive. They release hydrogen ions, which are H plus, in water. So when you place them in water, they release hydrogen ions. Safety rule, never taste unknown chemicals, okay? So always have a parent supervision when you're working with chemicals or anything that's known to be dangerous, even if it's a tad bit. So lemon juice is an example of acid because it contains the citric acid and it's a pH of 2 to 3. Vinegar is also another acid. It contains the acetic acid and it also has a pH of 2 to 3. Finally, we have the stomach acid. Yes, the acid in your stomach, which contains hydrochloric acid and it has a pH of 1 to 3. So all of these are examples of acids because they have a low pH, which directly shows us that they are known to be acids.
And the lower the pH, the stronger the acid is. So stomach acid is pretty strong. Now let's talk about the acid power, what they do. The power of acids. Acids release hydrogen ions, which look like H plus, in water, which gives them their special powers. They can dissolve certain metals, they can create fizzy reactions with some substances, and of they can change the color of indicators. Now let's have a small experiment prep. Collect these acid samples: lemon juice, vinegar, soda, and orange juice. Safety tip: always ask an adult for help with experiments.
And now let's look at the bases. So these are some examples of bases: soap, baking soda, and ammonia. Let's look at why soap is a base. It has a pH of 9 to 10 and feels slippery. Since it has a high pH, it just shows us that it's a base. So in the pH scale, the lower you are, it's highly likely it's an acid, and the higher you are, it's highly likely that it's a base. And then we have the baking soda, which has a pH of 8 to 9. And it's known as sodium bicarbonate. And just remember that, like Kritika said before, on how the lower it is, the higher the acid, is just the opposite of bases. It's the higher the pH number is, it's how much powerful that base is. Ammonia has a pH of 11 to 12, so it's highly high. It's a high concentrated base, and it has strong cleaning base. Safety rule: never touch or taste unknown chemicals. Bases can feel slippery because they react with oils on your skin. So it's better to have parent supervision and ask a parent before you do anything.
Mm-hmm. Well, not with soap because you're trying to wash your hands, but if you don't know the chemical, then to ask an adult before you just try to figure it out yourself. Now let's talk about the base power. What bases do. There are certain characteristics of bases. They release hydroxide ions, which are OH minus, in water. They feel slippery, like Lassie said earlier, for example, soap, and they can neutralize acids. Also, they're really good for cleaning, because you might have noticed ammonia, like we mentioned, can be used for cleaning, and then soap, you use it in your everyday life. Now, here's another experiment prep. Collect these base samples. Baking soda solution, so dissolve 1 teaspoon in 1 cup of water, and then liquid soap diluted with water. So just add water in liquid soap. That's how you dilute anything. You add water to it. And remember to, this is a safety tip, but it's optional. You can wear safety goggles if you have them. And I'm not saying you have to go and buy them just to mix baking soda and water, but just in case.
Now let's talk about the pH scale, measuring acidity and basicity. Acidic is from the pH of 0 to 6.9. So anything in this range is known to be acidic. So the lower the number, the stronger the acid, like we said before. Examples are lemon juice, which has a pH of 2.5, and vinegar, which has a pH of 3. Next, neutral. So neutral has a pH of 7. Pure water is neutral, neither acid or a base. Finally, we have basic. So a base's pH is between 7.1 to 14. The higher the number, the stronger the base, like we said before. And the examples are baking soda, which is 8.5 in pH, and soap, which has a pH of 9.5. Key idea: each pH number is 10 times stronger or weaker than the next one. So it's really important to know how strong an acid could be the lower it is, and how strong a base could be the higher the number of the pH is.
Now let's talk about indicators, the colorful detectives. Indicators are special substances that change color depending on whether they are in an acid or a base. The first indicator is red cabbage pH indicator experiment. So boil chopped red cabbage in water for 10 to 15 minutes, with adult help of course. And that is one of the, you can also search this up for a better explanation, but red cabbage is a pretty good indicator of the pH level. And always try to search up a pH scale so you can have the exact scale that we don't have a picture of right now. And then strain the purple liquid. So the purple juice is your indicator. Let it cool before testing. Now test different substances. Add drops. Add drops to the purple liquid. So lemon juice should turn red or pink. Water should stay purple because remember it's neutral. And then baking soda should turn blue or green. And soap should turn green or yellow. And the reason why there are these colors is because the pH scale, when you search it up, it gives you the exact colors, and that is the color range. That is the type of color that that should show up on your cabbage or on in the water, the juice. And remember, you should always have adult supervision, especially if you're handling hot water and chemicals. So always call an adult every single time we tell you to do an experiment. Don't try to do it alone, kids. It's not easy.
Now let's look at what neutralization is. It's when acid meets the bases. What happens during neutralization? When acid and a base mix, they can neutralize each other, making a more neutral solution. It just means the pH is more closer to 7 now. So this reaction often produces water, a salt, and sometimes gases like carbon dioxide.
Now let's talk about chemistry. Chemistry is all around us. So let's talk about a summary of everything we just learned. We learned about solutions, which are mixtures where substances dissolve uniformly. And then we talked about acids, which are sour substances that release H plus ions in water. And then we talked about bases, which are slippery substances that release OH minus ions in water. And then we talked about the pH scale, which measures how acidic or basic a solution is. And remember, acidic is at how low the pH is, and basic is how high the pH is. So the exact amount was 0 to 6.9 would be an acidic solution. 7 is for pure water or neutral, and then 7.1 to 14 is for bases. Now it's your turn. Keep exploring. What other acids and bases can you find safely at home? Remember to always work with adult supervision and prioritize your safety first. So try to do all the experiments we give you. Always have an adult with you while doing these experiments, unless we state that you don't need one. But it's always safe to always have an adult, one of your parents or one of your siblings, older siblings. And that's all we have for you today. Comment down any questions and also comment down what acids or bases you found at home, because I'm curious what you guys were able to find. And if you have any questions, concerns, video requests, or anything at all, you can comment down below. We look at all of our comments, so don't worry about us missing out on your comment because that'll never happen. And that's all we have for you today then. See you in our next video. Goodbye.
Bye, Stepsters.